Hello all, good afternoon. I'm Vikrant here from Manifold, and welcome to this webinar on upskilling EV industry in India, particularly for product design, testing, and calibration. I will give a brief context and run through some slides on my understanding of how product design works and how virtual process helps. And after that, we will have Arindam go through the context setting again and introductions of the panelists, and then we will have a discussion in the form of question answers. And in the end, we will have the audience Q&A. So we'll start with where we stand as a country in terms of electric vehicle acceptability. There is a report by McKinsey on electric vehicle index in terms of market adoption as well as the industry leadership. And in both of them, we are pretty lowly placed as of now, although being fifth largest motor manufacturer globally in terms of passenger cars and commercial vehicles. And then we also have a huge two-wheeler market, which is many folds bigger than the four-wheeler market itself. And despite that, we have places to go as of now to be conducive to the electric vehicle acceptability in the market. So, what are the typical drivers for this? So I got this from the PwC report that was made for SIAM, and it kind of focuses on how the automotive industry is developing for the future, gearing up for the future. And these are the 7 major shifts, paradigm shifts that the industry, particularly the OEMs and the suppliers, will see in the coming years as they gear up for new technologies, including the electric vehicles. So basically, out of the top 7, 5 of them are actually directly influenced by, or they directly influence the product development and its engineering. So through my experience of nearly 2 decades in automotive industry, this is kind of the product development process that I have worked with, and I'm sure a lot of you are familiar with this as well, where we start with the voice of customer or the customer requirements, also the relevant regulations and the business needs where we want to position the product. From there, we derive vehicle targets or vehicle specifications, which are predominantly in terms of the attributes which are perceived by the customers. From there, we derive the subsystem targets, and from there on, the selection of the technology, selection of the subsystems and component design, all those things start. And from then on the right hand side of the V, what we look at is the validation against those targets which were set for the components, for the subsystems, and eventually for the vehicle. And where the virtual engineering helps, and where I have seen it being used extensively and to a very good effect, is all of these aspects of product development. So we have something called functional models, which are more representative of the system, the response of the system. And these functional models are typically used for setting the targets, realistic targets at vehicle level, also deriving accurate specifications for subsystem and components, and then further for all the design for Six Sigma studies, system optimization, iterations, and so on. We also have something called behavioral models, which are more intrinsic to the system itself or the subsystem itself, where we study how the subsystem behaves internally to provide the response that we looked at in the functional models. And those models help us again do assessment of the designs, do failure mode effect analysis at subsystem and component level, and we can also do subsystem validation for durability and robustness. And then again, the utility of the vehicles, the features, the reliability of the vehicle, all of those things can be studied at vehicle level. And all of these iterations traditionally were done on prototypes, which is more and more moving into virtual space now, because it saves cost, it enables a lot of robust choices because you're not constrained by how many iterations you can do, what you can simulate. You can simulate the summer of Rajasthan or the winter of Ladakh sitting in your computer. So all of these enable us to generate lot of information, and when you have more relevant information, the choices that we make are robust. So I will take an example of how we derive accurate specifications from vehicle targets using the functional models. So typically any functional model is usually a 1D model in softwares like MATLAB Simulink, MSM, or SimLab. And what it is the basic representation of how the vehicle behaves and what are the inputs to it. So basically the powertrain traction, the brake, and the vehicle behavior itself in terms of the road loads, in terms of its aerodynamics, in terms of its rolling resistance, and so on. And then finally the road profile, which will dictate the grade and also your vehicle speed versus time. So using all of those, what we can derive is the vehicle requirements for satisfying particular targets or expectations from the customers. And those we can again cascade down to subsystem level using the virtual models of each of those subsystems. So just to take an example, typically the voice of customer or the marketing is not in technical terms. It is usually in terms of uh, how, for example, the car must go faster than competition with good range. So how we understand this as a vehicle specification is faster than competition usually will mean we want to be best in the target segment or in the top 10% of that segment. And then good enough, better than average is usually where we say that the segment average, we want to be better than that is usually the target. So this is based on the product positioning that the corporate wants to do. From there on, how we derive the subsystem specifications. So the relevant subsystem specification for, say, acceleration time, which denotes the pickup of the vehicle, 0 to 60 times, which we read in magazines. So what directly relates to it is the wheel torque and the range, which is again a important attribute that the customer cares about, is dictated by how much energy capacity the battery has. And from then on, if we have those, we can go down to the component specifications. What is the configuration of the battery pack, which motor to use, and so on. So using a simulation model, something like what you see in the top window, we can arrive at what wheel torque gives me a decent 0 to 60 kph time, for example. So this is just an example. There are many metrics that you can simulate and do trade-offs. Similarly, for vehicle range requirements, you can do a regulatory cycle or you can do a customer cycle, which you are targeting, and use that to calculate what is the range expected on your vehicle, and also keeping in mind the life cycle of the product, because the vehicle as the vehicle runs and the charge discharge happens, the battery ages and it loses some of its capacity. So as I said, from those two simulations, we can fill up these blanks where we say 800 Newton meters is what is my wheel torque requirement, and 20 kilowatt hour is roughly my battery capacity requirement. And then we get down to the trade-offs, down to subsystem and component level. So a couple of examples here are the motor selection, also the torque multiplication or the speed reduction selection, and then the battery sizing for the range. So coming to motor selection, typically what dilemma we have is whether to go for a max speed or pickup. So usually for pickup you need higher gear ratios, higher torque, and for max speed you need the motor to run at higher speeds and still producing good torque to give you peak power at very high speeds, and preferably a smaller, numerically smaller gear ratio or the torque multiplication ratio. So as you can see here in this example, if I want to achieve my full load acceleration, I can, if I choose a certain gear ratio that gives me only 102 kilometers per hour max speed. It could be fine for your product, but if it is not and you are actually looking for more, that's where you get into a scenario of trade-off. Another typical trade-off that we see is in battery sizing, because we need to satisfy from the battery two requirements. One is the energy capacity and second is the power capacity. So you can see here on the right hand side, if I balance for my energy capacity, I usually fall short for my power capacity. And if I cater completely to my power capacity, I am usually quite high on my energy capacity. It's kind of a over design, and it also pushes cost and cooling requirements and so on. So this was in brief how virtual simulations can help take these decisions early. So just to summarize the benefits of the systems engineering approach to product design and to see how virtual simulations complement that approach. So first of all, systems engineering approach is focused on the end usage, and virtual simulation models, they can bring in this end usage right at the start of the program or right at the start of the product development, and you can actually start thinking about that right from the word go, even before you select the subsystems, the technology, start designing the components and so on. So it provides a very good way to get accurate technical specifications. It also prioritizes an optimized system rather than a great individual subsystem. One of the examples that I recently saw was, usage of fuel cell. Fuel cell itself is a brilliant individual subsystem, but it doesn't fit into an optimized model, economic model for a lot of product as yet, because the technology cost is still very high. So there are many examples like this where a lot of things are being tried out, but they are right now not possible to be optimized as part of the entire system. And here again, a virtual simulation can help you do selections and also optimization studies uh, uh, very early in the program. Otherwise, you would have to wait for prototypes, very costly prototypes, which also are functionally accurate, but they do not have the durability and so on. The trade-offs that are made by this approach are more robust because they are inclusive. Think about multiple dimensions simultaneously rather than only thinking about range or only thinking about pickup or only thinking about range. We look at it in a holistic and again in the virtual simulation models help you generate all possible scenarios that you would need to do those trade-offs in a proper manner. In systems engineering, the traceability is a very big advantage because any failure that you detect early, any root cause analysis, you can, just like we cascaded down the specifications from requirements, we can trace it back up through the same ladder, any issue that we, and the system models help us catch those failures much early again, because because we can have behavioral models which accurately represent the subsystems, and we can simulate those and see what failures we can anticipate. And not last but not the least, it helps us drive standardization by enabling very precise subsystem requirements. Typically for electric vehicles, we have a scenario where coming from IC engines, where the powertrains or particularly the engines were built in-house by most of the OEMs around the world. Whereas in the electric vehicle, the motor design and those skills are not inside the OEM. The motors have been designed and developed since many decades, and there is no point in OEMs to invest trying to create that skill now. So a lot of times OEMs go out and get those. Now that's where the specifications become very important. It is quite different to deal with an external supplier for your powertrain as against dealing with your internal engineering departments. The flexibility and also the volumes and all those leverages will pull you away from being very specific for your very specific designs for your requirement. So that's why standardization in today's context will be very important. And how virtual simulation models help is, despite having standard subsystems, you can still give that unique identity to your product by exploring the bandwidth that you have in terms of the controllers. The controllers you can use the controllers to tune the subsystem in a unique manner to make your product distinct from the rest of the competition by using the same subsystems and components. So with that, I will turn it to Arindam to go through the introductions and context setting.
Thank you, Vikrant, for this wonderful overview of the challenges in the EV space as compared to the traditional IC engine systems design perspective vis-a-vis what we want to do in the EV space. In fact, last year we had commissioned a skill gap study, and one of the key findings within that study was, of course, that the new skills that will be required for people getting into the automotive segment will require a greater understanding of electric vehicles and on a larger scale, I think, understanding of automotive electronics in general and the subsystems impact around those adoptions that are happening in terms of much more connected and autonomous or semi-autonomous kind of vehicles that we have in use in today's context. So we have a great panel here today to talk to us about some of these challenges and their views around this. So let me just quickly introduce the panel. Let me start with Mr. Irfan Singhvi. He is the chairman of the Education, Skilling, Training and Mentorship at ACMA, the apex body for the component manufacturers in Indian automobile industry. And he is also the joint managing director at Sansera Engineering Private Limited, one of the leading auto component manufacturers in this country. So he is by profession a chartered accountant, and he is also India rank holder. He is the founder partner of Messrs. Singhvi, firm of chartered accountants, and also founder director in Messrs. Woodder India Private Limited, a world-class unit for manufacture of ceramic decals, and Messrs. X Dion, a KPO company. He's also very deeply associated on a lot of social activity front, managing the Sansera Foundation directly, which is looking at more than 5,000 children studying in 28 government schools and 10 private run schools. Plus, there are many other projects in improving environmental and civic infrastructure, and very active within the state of Karnataka itself.
Thank you,
welcome, Mr. Singhvi, to the panel.
Thank you. Thank you.
So should I start? Thank you, sir.
Thank you.
I just introduce others very quickly. We can get started. Mr. Prasant Banerjee is the Executive Director of SIAM. He is, Mr. Banerjee, if we could request you to switch on your video now. He is an alumnus of the prestigious Indian Institute of Technology, Mumbai, and has more than 30 years of automobile technology. Automobile industry experience. He has worked in the past in the areas of engineering development, localization, advanced technologies, certification testing, regulations, and standard formulation roles in various multinational companies, namely Toyota, Daewoo, and Tata Motors. And he is part of a large number of committees and bodies in the country and abroad, including Society of Automotive Engineers and the United Nations Committee on Vehicle General Safety. I welcome Mr. Banerjee. I think he's not on the video, but we'll see him soon. Next, we have Mr. Kaustavan. He is the founder director of KAT24 Techno Solutions and Engineering Consulting, and also a senior technical advisor at Ola Electric. He's an engineer from NIT Surathkal, an MBA from IIM Calcutta. He's got international and multicultural experience, having worked in organizations like Maruti Suzuki, Tata Johnson Controls, Onward Technologies, Renault Nissan Technology, Cummins. He's currently, as I said, senior technical advisor to electric mobility. Thank you, Mr. Kaustavan, for joining us today on the panel.
Thank you.
And we have Dr. Chandra Rengaraj, Vice President Engineering for Ather Energy. Chandra has about 20 years plus experience with product development, very apt for today's context. In his roles, he has led R&D teams at OEMs like Mahindra Electric Mobility, Jaguar Land Rover in UK, and Tata Motors. He's received his doctorate in vehicle dynamics and control. He's developed low carbon vehicle programs for automotive industries in UK, and he's also supported local skills development agency in the UK to identify skill gaps amongst youth, to train and upskill them and make them more employable. And he is currently part of the team that develops India's fastest and smartest electric scooter in Ather Energy. Thank you, Dr. Chandra, for being part of this panel today.
Thank you, Arindam. Thanks for the introduction.
Thank you all. Vikrant, I would hand it over back to you, and you could start with and to the respective panelists. Over to you.
I'll just lay out the discussion points one by one, and we will start the discussion. So I think the first question is around how the product development process is set up in the automotive industry, and what is the role of virtual engineering, and how going forward this will play out in the product development. So I would probably start with Mr. Kaustavan. How do you see this development cycle in your experience in automotive industry, and how would you like to see it?
Yeah, thank you, Vikrant. The automotive industry development process, I mean, is the handover and takeover. So the handover is done as previously by the marketing and departments like product planning. Once the product definition is clear, what exactly is the product to be launched, then there is a styling activity, which is what kind of styling. So after the styling phase, that V that you showed earlier in your presentation, V development process comes into picture. So what is the V development process? So on one half of the V, we have the virtual development, and the other arm of that V is the physical development and physical validation, and finally getting out a physical part. So what is to be emphasized is the virtual part, or the first part of that V. The first part of the V starts with the vehicle level concept, starting from the product definition, what is to be launched, and then we have to go into system level and down to component level, along with the hardware and software optimization specifically for electric vehicles. which is a little more complex as per me as compared to a IC engine vehicle. So in this, the 1D simulation, I would give great importance at the beginning of the one left arm of the V, followed by 3D simulation. And on the software hardware side, I would emphasize on the model-based development, we call as a model in loop or software in loop, on the left-hand side of the V. On the right-hand side, then once the concept is clear, that it can meet the targets that you are going to set, that it's going to meet the targets of the product planning and the styling. Then, of course, there's the physical build involved, prototypes. Then prototypes have to be made, then they have to be tested, hardware in loop testing, and followed by the realistic testing. And then, of course, after that is the homologation. Homologation, of course, meeting the government regulations and unstated requirements like FAME, which is not a regulation but a requirement, get the eligibility for incentives. So regulations and FAME to everything combined, if it meets, then the vehicle can go to a stage where it can be launched, meeting all the quality targets. So in short, in 3 minutes, that is the new product development cycle as we follow in various automotive OE.
Yeah, thank you. Coming to Mr. Banerjee, where do you see this going forward? Do you think there is any big difference in the approach that we have to take?
Thank you. Sorry for my internet connectivity issue, but nonetheless, I'm back. I'm first of all very thankful to ASDC for giving me this opportunity to present my view on the upskilling, reskilling, or multi-skilling of EV scenario. And in EV realm, as an engineer, I think the first and foremost EV is standing in a very, I can say, odd situation in vis-a-vis IC engine. So first and foremost, which comes to my mind is that weight targets. IC engine is anyway, with regards to the sustainable goals, lightweighting is one of the main issue. And I think, as you explained, the product development sequence, starting from quality function deployment in the marketplace with the customer need assessment, to the target setting vis-a-vis with whatever price positioning you want to or intend to do the product. I think target setting is very important, and target setting goes by not only the targets of performance, but also the targets from all sides, including the knowing the supplier base, knowing the constraints of available technology, and also you have to have a risk of what kind of changing dynamics in the technology front is happening. So with that, I believe, because the connectivity, autonomous, and of course shared mobility is going to be the future, all the more important that the development cycle time has to be very, very squeezed in. So front loading you must do in your digitization program. So right from the rapid prototyping, virtual simulations and digitization, digital CAD based system for the validation of the early prototypes, and then testing simulations on the software basis without having to do physical proto vehicles building and doing the multiple iterations. Even in fact, the road load data management and the management of the customer usage pattern, all those things actually can be done on the virtual world. And that's where I think we need to focus our skilling requirements, and we should prepare our ecosystem for this kind of support. So this is my initial thought on the subject.
Thank you. Coming to Dr. Chandra, I think you're deep into this. Even when we spoke last week, you were talking about exactly this, I think. So your thoughts on this? If you want to use any props, let us know. We can let you share the screen as well.
Yeah, sure, definitely. Thank you very much for that one. I think if you can just send me a request, please, I can share my screen for a moment.
Yeah. So, Snail, can you just quickly pass on the controls to Chandra?
Can you see my screen now?
Yes.
Yeah. Yes, Dr. Chandra, you can go ahead.
Okay. Good afternoon, everyone. First of all, thank you very much for giving me this opportunity. So it's a quite interesting topic. In the first of all, product development is actually one of my favorite. Definitely. So what I actually heard from Srivatsan as well as actually from Mr. Banerjee, I completely agree that the product development cycle, the traditional cycle, has got multiple phases. So knowing OEMs and then experience in their product development processes, it can be like a 3, 4, or 5, or 7 stage process. So it starts from the concept delivery and then goes to the launch and production. So where the concept basically starts with the voice of customers or the market requirement, and how the strategy and the concept and theme of the product evolves, how the product gets confirmed in terms of going into the program start stage, and then the detailed and development activity happens throughout the delivery stage. Then it comes to a point where we get actually industrialization starting, going into the launching stage of looking at all the manufacturing engineering aspects of the product development, then finally going into the sort of production. So that is actually quite typical and standard in terms of industry, whether it is actually an ICE vehicle or whether an electric vehicle. This logic is still actually the same as well. And so can you see my screen? Yeah, is it okay?
Yeah.
Yeah, okay,
Yeah.
fine. So that's actually no different to whether it's an electric vehicle or whether actually an ICE engine mainly. Again, the key factor which what I actually would stress in terms of product development is that system engineering, which again touched by some of you here already, which is quite critical, and that I would again think that will play a very critical role in developing more complex systems like an electric vehicle. So the typical V model are here to say the fundamentals, system engineering and the system V development, and then the gateway approach of product development. They're all here to stay, whether we are actually developing electric vehicle or an ICE vehicle. But coming back to the virtual engineering and simulation point of view, so definitely the virtual engineering is, we are not new to virtual engineering tools and methodologies as far as product development in automotive industry is concerned. But the use and the advancement of the tools are actually increasing, and definitely a lot of earlier gateways. So Mr. Prashant said that the left shift, that's quite critical, because now we are actually using a lot of virtual engineering tools to get an answer to prove a product much early in the product development system, mainly because of the complexity of the product itself and the most technologically advanced product in nature. So we need to get those answers. If a customer actually asks for something, looking for something, how is the product growing and developing? So those questions are actually currently being answered and will be answered more in terms of product development. So now we are actually looking at the mathematical modeling of say the EMI, EMC behavior of a design, power integrity or signal integrity or vehicle handling and dynamics, thermal management. Everything is actually currently now, whatever is applicable for ICE vehicle, it has now actually gone more in applications wise. This is actually what I see. So traditionally product development is not changed, that's fundamentally the same, but the virtual engineering tools helping us to move towards the left. This is actually what, in my perspective, I would just would like to add here further for the particular question.
So I would like to add
questions.
one point.
I'll, yeah.
Which is a very good presentation by Chandra. And so one of the key differences that has happened with an electric vehicle as compared to an internal combustion engine is things like brake energy recovery, brake energy recuperation. With an ICE vehicles, there was not a generator, starter generator mounted. Now with electric vehicle, we have to increase the range as much as possible, given the constraints of the battery and the energy content that it has. So we are trying to recover as much brake energy from the wheels as possible. These are all new which have come about with the advent of electric vehicles, and it does affect the product development cycle from the beginning to the end, which was not so in the case of the IC. There are many things like this. I just mentioned one such factor.
Thank you. Coming to Sanjay sir, how do you see this product development process complementing with how the suppliers come in here, how they benefit from this? What are the things from their perspective that are missing probably in this? Your thoughts on this?
Yeah, basically, I agree with Chandra that there's not much of a change to the current technology of IC engine and EV engine as far as product development is concerned. Let me give you a direct example of my own company that we are mainly into engine parts. And it's almost like last 5 to 7 years, we would have developed about 30 to 40 parts for customers across the world, where we are only given specs. We do concurrent engineering, and then we do 3D modeling, we get it approved, we do the virtual testing after the product is done on the computer, the design. And then when then it is even gone through a staircase test, and only then we take up for manufacturing. So this is already there, fairly advanced in auto sector, and this is exactly, and it's moving forward more and more. Like 2 years ago, when we acquired a plant in Sweden, we did, and we had to shift from one look to another. We used the Siemens Advanced Engineering System, not only to do a virtual factory design, but using the existing machine, looking at the takt time, the cycle time, the labor that is currently used, the automation currently used, and we worked out as to what is the way forward for the next 5 to 10 years. How many robots are going to replace the human people? What is the kind of changes we need to do? How do you compress and work it out? And these were, students who had passed engineering 3 years ago, and using the advanced engineering system from Siemens, learning that in 6 months, we were able to virtually design the factory, and entire activity of setting up was done with 2 people in Sweden and 2 people member team here doing it, which when we originally started, our Swedish team wanted 9 consultants. So this is something that is already there in India, and it's very advanced in engineering. It would, in EV vehicle, it would be same, but I see one challenge in EV vehicle is when I saw the design that Chandra showed on his product design. Now, automotive today has about more than 5,000 parts, and so all these can be done here. And but these parts, when they're designed, like we deal with connecting rods and engines. So engines, these parts go on with unchanged for 5 years, 6 years, 7 years engine life today, which used to be earlier much more. But when it comes to electronics and electric, I don't think that the technology would be that long. Either might design a card or a chip or their electric board for the vehicle, and in next year somebody will come with more advanced aspects, more features, everything. So today, like, you can afford the luxury of designing engine and let it run for 5 years, 8 years. The OEM, the component manufacturers, they can amortize the cost over 5 to 7 years. But in case of EV vehicles, the design aspects of most of if you take EV vehicle, you take out the activities relating to bodies, chassis, driveline parts, brake system. These are all currently existing, and they will continue. But the core of the technology, uh, and leave out the batteries and the motors, which will be done by the large players. But the rest of the electronics, everything that would be done, and they change so rapidly. So how do you really, the testing period, everything, can the OEM really do it, or it'll again be like there's a separate company with like you have Intel supplying the core of the computers, you have somebody else supplying. It is more of an assembly activity that is being done. So in that case, all these design activities, which in OEM case, to a large extent, it was done in-house for many years, it is slowly moved out to companies like us. But in case of EV vehicle, I think from the starting point itself, A OEM will be more like an aggregator of parts, assembly parts, like in aerospace now today, an aircraft manufacturer. There's very little of manufacturing that really takes place with the we don't even call them OEMs, we call them aggregators. So I see more of that concept happening in EV. So design and all these will become a core activity of individual suppliers who are like, you have motor supplier, you have battery supplier, similarly you have system integrated supplier, all these. So they would be doing all these activities seriously, not just as a tier one supplier, but they will be the proprietary suppliers for all these. And that is where I see the change. And there'll be a rapid change happening. So your virtual testing, everything will have to be very, very frequent, not like every 5 years or 8 years you change.
Very, very interesting perspective, sir. Thank you. That was something, very, very good. So, moving on to the next question, Vinda.
Sorry, you want me to start now? Yeah.
Yeah.
Okay, fine. Yeah. Shall I share the screen for a few minutes?
Snail.
Is it okay? Can I share it now? Is my screen visible?
No.
Okay, I think I'm just waiting for the invite to be shared.
Chandra, just 1 second.
Yeah. I think Arindam, you can probably just phrase the question by the time.
Yeah, okay, fine. So what we basically are now looking at is that given this, context of what we currently do in product development, testing, prototyping, etc., and some of the changes that we anticipate in the electric vehicle, what are the kind of particular skill gaps in EV teams that we foresee as compared to the mature IC engine industry? The IC industry, and what kind of trainings will be beneficial if we were to transition the existing manpower into what is relevant for the EV industry? So, yeah, Chandra, we can see your screen.
Okay, no worries. Thank you very much for the context setting. So I think when the question was asked, I was just thinking about the different kind of trends that actually is currently happening, and then what people are expecting to go towards in the coming years. So if I actually try to group them into 4 different areas, and as Prashant mentioned earlier, the case, which is basically people call as A's and cases. So the connected cars, autonomous, shared and electric, the disruptive trend of technology that is actually is already here, and which is going to drive automotive industry towards the future, is one of the key trend or the combination of trends that actually will dictate the skills requirement and development of the automotive industry in the personal view as well as the industry view. So when we look at that, it is actually no longer we are just an individual automotive an industry. Actually there is a merger of technology happening. It's like a technology world, the predominantly software industry, the technology world, like Google and everybody, all the software industry, they're coming together and then merging with the automotive industry. That is a great fusion. That is actually what's happening at this point in time, and then towards the future. So yes, we're talking about electric vehicles, but electric vehicles are no longer electric vehicles nowadays. So it is actually a largely connected vehicle, and we are also seeing a large amount of shared mobility. And yes, autonomous is actually here to stay for a longer time. So that is actually the key aspect that I believe that we need to take into account when we want to assess and develop the skills, especially for the young and growing India automotive industry. And the next one is actually the product development. So traditionally, we have seen the traditional product development where there is a requirement coming, and then we are actually trying to understand it, decomposing using system engineering, trying to develop complex systems, components, trying to verify, and then using virtual engineering, traditional way of doing things. But now product development is actually slightly going towards more and more data driven, and it is more predictive actually. So for example, like we have a vehicle with a lot of sensors on it, and we are getting a huge amount of data. So the data is actually and will be driving the product development in the future. The way how we are trying to like give a customer experience, and also trying to meet the customer needs, or even trying to define the customer needs for one customer. So everything is actually currently being driven and will be more as a more predictive kind of a product development. That is something which I would like to highlight here when we want to talk about skills development and skills gap. The third one is actually the business agility. This is actually something I want to highlight from my experience across the industry here, because when we talk about that, the business agility is a combination of how a business is actually developing a strategy, and then how are they executing it, and how the leadership is coming together to deliver the strategy. And that is quite key, because it goes to the first topic over there, the case, because the case is a combination of technology and automotive. This business agility is predominantly we are deriving from technology industries as well. And now there is actually a little difference. We are meeting more and more the technology in automotive, how they do business in a very agile environment, flexible, changing requirement. How do we react? All of them are actually now upon on us on automotive industry. So we have to be now more and more agile. That's another thing. And again, that links to the skills and people knowledge and the ability to come and perform in automotive industry of today and the future. And the fourth one is definitely the industry 4.0. So how do we use the Mr. Singhvi mentioned about the Siemens tool, the complete integrated digital solutions. So how do we use that to automate our manufacturing processes and our industry, and also actually how are we trying to robotize and measure our future manufacturing, especially when we are talking about electric vehicle. There are a lot of electronics and electrical components. So this actually makes more and more sense. So in a nutshell, we are going towards a data-driven tech auto fusion world, and which are actually supported by the completely integrated digital solutions. This is actually what came to my mind when this question was asked. I'll stop it here. I'll just hand over. Yeah.
Thank you, Dr. Chandra. I think that's very useful, because it helps us connect the connected vehicle scenario with Industry 4.0 and how it overall impacts the skills. Mr. Singhvi, I just wanted to ask you about, how does the upskilling impact the overall cost of the product, or even the engineering cost, let's say? Do you see a correlation between the two, and are there any merits in terms of pushing through the cost for upskilling, because it will eventually impact somewhere in the cost of the product?
Yeah, I mean, if you talk in general as an automotive industry, I think automation, be it Industry 4, be it on AutoCAD solutions being used. Like today, we used to make fixtures. We had a team of 20, 30 people. And today we use software, that same product, we just need to change parameters and you get fixture design in matter of 15, 20 minutes. So these are the kind of things that they are definitely cost effective. Initially, yes, investment is huge, but when you look at a cycle of the software cycle and upgradation and usage, it all works out to cheaper. And that's why you see in India that component costs in the last 10 years or 15 years, we have hardly changed it. Every year we continue to give discounts. One is because volume has increased, but second one is all these innovative ideas are being used. So there is an advantage of using technology. To me, maybe initial capital involved, but long term it definitely pays for itself, because generally in our industry today, when we look at automation, depending on like small cost automation, we look at a payback period of 1 year to 2 years. A major automation like using an automated line, I would look at a payback period of 5 years. So after 5 years, it is virtually zero cost on labor, whereas labor is each year increasing. So digitization to me, or total tech auto fusion, what Chandra said in his in a presentation, would definitely overall reduce the cost, and it will not really increase it. But what I see here challenge when it comes to EV vehicles, upskilling. To me, I see a huge challenge with the existing companies like us. It's a paradigm shift. I mean, that you have now. You have over 5,000 suppliers, I mean, component parts in a car, and here there are only hundreds of parts. And if you look at a scenario, if I were to imagine a scenario of EV vehicles, like I said earlier, that there will be proprietary product design, be it batteries, be it motors, be it your chips, or be it your electronics, be it your software. And these are all the specialist companies which will provide their own design to the aggregator. Now, who are the aggregators? It could be like, for example, today you can assemble a computer. You can buy parts in the market and you can assemble. So you have on one side of the spectrum, you have computer being assembled by a school kid. And on the other side, you have software companies like Google and Apple all getting into where the cars is, even the normal IC engine cars today, going forward, 30 to 35% value of the vehicles will be software. So software companies are making a big inroads into IC engine vehicle itself, and EV vehicle, autonomous vehicle that we talked about. It's going to be more and more. Their share in a value of the car will be higher than the hardware parts. So who's going to own what is a big question mark to me. So when I look at a company like mine, to what extent can I really upskill for EV industry? I would say I have to upskill, not operator would be the least of the problem. I probably don't need most of the operators and I don't need to upskill them for EV industry. What I need to upskill is right from my level onwards to all my white collar jobs. My engineers who are into mechanical engineers. And today when we are wanting to get into core activity of EV vehicles, we find ourselves at a loss of knowledge in our company. Despite having over 200 engineers, I can't imagine my company having enough knowledge to seriously have a good, proper discussion with the electric vehicle manufacturer on their core product, be it motors, be it batteries. So that kind of skilling, can I do it to my engineers today and bring them on? It could be very difficult. I will have to bring in specialized engineers who have done a very specialized course on electric engineering. Today we employ mechanical engineers mostly. I'll have to start with a stream of electric engineers and electronic engineers and get them into my company, and then slowly also try and upskill the existing people with certain basic knowledge. But I think we need specialized people for some of the core activities of vehicles. Barring that, digitization, integrated, data driven, these are all common factors for my company going forward in IC engine or EV engine. That upskilling is definitely required, not only on the technical side. I would say we have to seriously look at the non-technical side. Like, for example, now the kind of, from accounting softwares, we have most of the companies are into ERPs, but ERP, so much of automation is today possible. And today I can tell you, having SAP for over 15 years in my company, I am still struggling to get the right people of SAP who would fit my and who would be able to understand my company requirement and would give me a proper solution. So I'm just giving that example of SAP, like so many activities now, bots and pods are coming in. So all these are areas where upskilling is required, be it in accounts department, be it HR department, and is not just restricted to technical side. So you will have to look at upskilling for a normal industry, be it in EVs or be it in non-EVs. These are actual activities where a lot of skilling activities have to be done, not at the worker level, at the staff level or in them. So ASDC has to actually upgrade yourself from looking at only ITI graduates or equivalent and you train them and upskill them. You have to actually go to the next higher and higher level to really get onto the world. If we have to become Atmanirbhar, we have to be global leaders. We need to actually upskill our white collar jobs, not only by way of their functions, but even by way of their attitude to quality and discipline in carrying out the activities. So that's the kind of upskilling I would look at.
I think that's a huge change, shift in focus and priority that you've kind of stated in terms of looking at the white collar jobs. And I think starting with some technical work itself, the non-technical part that you've also emphasized is surely something that ASDC will need to look at. Mr. Banerjee, very quickly coming to you. I know you have to move out in some time, but let me catch your ideas in terms of, how do you see current skill gaps effectively hampering our end product itself? A lot of times I keep hearing that there is an India product and which is not really a global product. And how does the skilling or upskilling or lack of skilling actually impact that kind of a scenario?
Thank you. I think India has mastered the art of IC engine. So powertrain has been actually the forte for us, and number of exports, what is happening from India, and the kind of engines we are building. We have acquired a good amount of skills. But when it comes to EV, I think right from the curriculum in the college, I'm in a couple of engineering colleges, board of studies, management of board of studies, where we have realized that I think there has to be complete overall of the engineering college curriculum focusing on the EV specific subjects being taught. So right from not only the important, like in IC engine we say 5C component, we should also have a very clear focus on battery management system, battery and motor and system integration is one side, but at the same time our engineers, as Mr. Singhvi rightly mentioned, that whatever amount of training we try to give to the reskilling of our existing manpower, I think it's a bit difficult and challenging task. Therefore, right from our graduate school program and curriculum, we will have to have a skill set development which are specifically needed. And now if I divide into the EV industry requirement, so there are some very advanced technology understanding needs, okay, where perhaps we will not be able to catch up with the rest of the world the way it is fast moving. But where we can catch up is that the applied activities, where perhaps our engineers, they should know what kind of charging infrastructures are required for a particular EV vehicle charging, and then in the vehicle itself we should know what kind of energy storage devices are there, what kind of battery management systems are working, how the motors are functioning, and if they are actually having a difficulty in terms of diagnostics, then how they are able to cater to that needs. So those are the areas where we should be able to develop our both vocational courses as well as the engineering courses. That will be of immense help and value to the industry skilling requirements. Otherwise, as far as the virtual design, development, testing and calibration requirement goes, there are fairly good advanced systems are available with ANSYS, Altairs and MATLAB and maybe Siemens. So those softwares you can run. So learning of softwares is one part, and then creating a different environment of testing, validation and design of operating situations, that can be done. But real ASDC focus should be that when the vehicle goes out in the marketplace, then how we have a skill set available in the market where these EV vehicles do not suffer the lack of eco preparedness. So that is where I would like to focus, that ecosystem should be prepared well. Otherwise, with the complex systems of EVs, forget about the connected and it's a secondary aspect of or tertiary aspect of learning. I think the primary requirement is to support electric vehicles in the marketplace, so that customer confidence is there, that yes, in my area if I buy an electric vehicle and something goes wrong, then there are some people whom we can fall back. And that's where I believe that EV industry should focus, and ASDC should also try to develop skill sets which are very fundamental and make the vehicle back in work. So that is the kind of focus I would like to give more.
Thank you, Mr. Banerjee, because you're right, because the entire ecosystem needs to be geared up. Vikrant, we'll be running short of time, so can you move on to the next question? And I want to come to Mr. Kaustav. Where we are talking about, creating the right teaching and learning ecosystem on site, at the industry locations and at engineering educational institutions, to get the newer manpower to advance their hands-on skills in terms of being able to, whether we are talking about designing, testing, or even getting involved in the whole manufacturing process. So do you think there is a possibility of doing real life projects, apprenticing in these kind of domain areas, or it will be too risky given that the product might otherwise suffer if we have people, youngsters, young engineers working on these real life projects? Mr. Costa.
Yeah, thank you. So I definitely feel that we lack a right teaching and learning ecosystem at the OEMs. So the OEMs, if you see a typical OEM scenario, most of the effort is going into launching cars and launching models. There is not much of an effort or a concerted effort to teach the employees. I'm yet to see that many OEMs, and this is a lacuna that we have. Like what Mr. Singh we also mentioned, and you had also mentioned, how do we bring up those people from an ICE background into a EV background? Because when you recruit people in the company, let's say we are recruiting, most of the people are not already working in an EV environment, because the ecosystem is consisting of companies which are in the ICE segment. So you recruit from there. After you recruit from there, but you have to make an electric vehicle. How do you do that? So there is certainly a need to teach them and to skill them in an electric vehicle to launch it. One of the principal things for that is to have systems engineering approach. Many of the people whom I have seen in the industry, youngsters, are very good engineers, but they have not been taught to have a systems engineering, nor have they had exposure to tools for systems engineering. So that systems engineering will include simulation. At the beginning, I talked about the simulation. Simulation today is mistaken by many people as a mere or a computer-aided engineering, but it has gone much beyond that. If you see European countries, Germany, and even in the US, if you look at the Tesla as a world leader, simulation starts from a 1D mathematical equation, a physics-based model, and only then after they create the CAD models, etc., they are doing the 3D simulation for structural analysis, etc., etc. If you take a motor, they are not suddenly making a CAD model and then doing the structural simulation or HFO. They start from the mathematical equation and the electromagnetic equation for the motor. What kind of windings? What is the concept of the motor? What is the philosophy? What is the architecture? They start working on simulation to meet the product requirements, and then they are getting into further digitalization. So the upfront work, the upfront simulation and conceptualization and architecture of the product is the area where maximum teaching, learning, upskilling has to be done at the OEMs, suppliers, as well as at the educational institutions. The next point is, I think one of you mentioned, Mr. Arindam, that the car is going towards a computer on wheels. Earlier, it was a wheels with a little bit of electronics. Now it's going to be electronics riding on wheels. Many of you mentioned Google and so on. Chandra had mentioned. With that, how do we bring in artificial intelligence and machine learning into this EV business is what we have to look at. So artificial intelligence can be applied to, let's say, a battery management system. It can also be applied to a motor controller. Machine learning can be applied to the vehicle, learning from the driver's user pattern. It can learn from the way the battery is behaving or the motor is behaving. And India is already very good. India has got strengths in bits and pieces in AI, machine learning, software development. But what we need is to integrate all this, bring it together at one place or at one location or at one company or at one college or many colleges. The second thing I wanted to say is many of the colleges that I've seen today, Mr. Arindam, do not have an electric vehicle. You will not find it in the campus. So I would suggest that OEMs who have an electric vehicle, who are already manufacturing electric vehicles, could have a partnership with the educational institutes, maybe donate or give. There could be a buy sell or a donation of an electric vehicle, so that the students in the colleges get to lay their hands on an electric vehicle. Many of the people I recruit or I interview have not touched an electric vehicle. So that is very important. After they assemble, understand the architecture of electric vehicle at the college level, they would become employable by the EV industry. And then that will solve what Vikrant Vaidya had mentioned in the morning, that India is number 4 in vehicle production, but the last in the EV ecosystem worldwide, as per that McKinsey report. Why we are last? These are some of the reasons why we are last. And if we solve these problems, we will get what you have written here as the hands-on skills at the college level. Then, of course, further simulation, etc., at the company level, at the corporation where they are working, and you will have the ecosystem. The third point is, all of us have been focusing on vehicle. The most important thing is the charging system as well, which is not a shortcoming for IC vehicles. We have gas stations all over the country. But for charging systems I would say it's a vacuum right now. And that is why customers are not going in pell-mell to buy electric vehicles. Sales are not as much as they are in China and many other countries. So that cyclic gap is affecting us. So I would suggest that we should have also a learning and ecosystem, not only for vehicle engineering, but also for the charging system and the charging industry. These are some of my thoughts to promote EVs.
That's very useful. In fact, your suggestion about some of the OEMs reaching out to colleges, and that's something where ASDC has been trying to play a kind of a support role in terms of making that match happen. And I think that's something which we'll keep our priority on in terms of having engineering colleges or diploma engineering colleges having exposure to this and being allowed to handle electric vehicles, so that they actually get to see what's inside. Because unless you do that, you may do a lot of simulations on the computer, you may still lack the understanding of how does all of that translate. So both you need to do both. You just can't do only this and not do that kind of thing. Anyway, Dr. Chandra, if there are any other specific inputs on this point that you may want to add, we'll be very happy.
Yeah, definitely. Thank you, Arindam. I think there are actually really valid points because I can feel all those points and relate to my experience, what I have come across. So if I just quickly look at the sort of a summary of skills that we actually discussed and required, definitely, actually, I think Mr. Singhvi mentioned that we need the EV subject matter expertise because we're talking about the high voltage systems now, embedded hardware development and software development, and also it's a combination of chemical, thermal engineering. So all those traditional systems are still here to stay, as well as the new addition of all those things. So I'm coming across a lot of good engineers across the industry. But one point mentioned by Mr. Srivatsa was basically about the system engineering. So when it comes to put together all those knowledge into like a useful and successful system and developing producing a function, useful function, that's actually where I definitely challenge in the industry. And in my personal view, definitely I would actually agree with the point that when we actually come to impart the skills and educations in we need to also teach the skills about how to bring things together, how to integrate them. So because we're not going to sell a component, we're not going to sell a system, we're selling actually a whole product value to the customer. That kind of a thing is quite critical. And next thing is, since we are actually going towards more and more intelligent systems, how we develop the hardware and software in parallel, which is another critical skill I actually see the industry needs to or the workforce needs to actually develop. And this will actually help the ability to left shift in terms of reducing the product development cycle. So how we can develop both. We can't just afford to develop any more hardware and then like hand over software, then integrate and testing. That's actually gone out of those days. And a third point which prompts me to discuss about the EV manufacturing. So we talked about the product development so far, but the manufacturing and the whole EV manufacturing, when we actually talked about the virtual simulation of the manufacturing lines and systems, and how are we actually going to achieve manufacturing excellence, all those things are quite critical. And the skills required to support that is actually a gap I would personally see in India. Definitely that actually needs, it's not actually possible. It's a skill which can be learned, but that is something where I would say we need to focus on to bring the workforce to a level where the industry can actually use them. So in summary, I would say, what, for the workforce or for in general, we have to actually know our basics as a workforce, and we need to be actually multidisciplinary and be agile in changing, for the requirement. At the same time, we need to be industry ready, and the industry ready is a quite critical word I want to reiterate here, because a lot of institutions are producing engineers who are not industry ready. And if I look at the ecosystems, yes, there is actually a formal education, then they come and do some extra courses, special courses to develop their knowledge, like maybe an EV specific courses. And then you can go and do an on-the-job training, and then maybe you go for lifelong learning. There are 3-4 different stages of like a ecosystem which I see. But the industry ready is quite critical. And when we actually develop engineers and look for skills, if you look at this particular aspect, and that is something I think we need to focus on going forward.
Thank you, Dr. Chandra. I think that's absolutely useful in the sense that we need to look at it at various levels, and including manufacturing, which you've rightly emphasized on. It cannot obviously stop at the product engineering stage. Vikrant, over to you to take the last question for the day here on the panel, and then if we have a couple of more questions from the audience, then we'll take that. Over to you. You are muted, Vikrant.
Thank you. Yeah. So thanks, Arindam. So coming to the last question, which is phrased around both the standardization of the subsystems and the components, as well as the quality standards. So standardization in terms of design and manufacturing, and then also in terms of how we approach the quality of the individual subsystem and components, as well as how we comply with the requirements, the quality requirements of the EV itself. So maybe we'll start with Mr. Singhvi on this.
I have very little to add to this, but I have a question actually to Chandra, because I want to, as a company, we are looking at which is the core area that we can get into. I mean, we moved from engine parts to body parts to driveline parts, which are common across, so that way we will be able to meet the requirements of EV vehicle. But how do I get into some core area which is only purely for EV? And it was a big struggle as to what a company who's into precision machining and forging can really do in the core technology. So it came to like batteries, certain parts of battery fins. Then when we looked at motor, and when I was talking to a manufacturer of winding wires for the motors, I understand that each customer, each OEMs will have their own specification of motors for the different products. So that means you have 10 companies, all of them will have their own specifications of motors, and different countries will have different specs. So you'll have India specs separately, you have US specs separately, you have UK specs separately. So this is very initial stage, the discussion that we did, it really put us a question as to if this is going to be the kind of total unstandardization, like our electric sockets and plugs. You can mobile phones wires. Every time you buy, you have to have, or everything is not standardized for a particular purpose. So if this is the kind of world that, if it's true, because my knowledge in this is Chandra has to probably escalate. But if this is what is going to be, how does one really get into a globalization concept of doing? I get into motor assembly. I mean, like Denso's and Bosch, they are all big players who are all into this. They would do the R&D, they will provide the technology to even to the OEMs. So I cannot probably get into these core products except as a tier 2 supplier. Now, even if I was a tier 2 supplier, if I'm going to do specs for Bosch, I have to again do separate specs for Denso. I have to do separate specs for a customer across supplying somewhere else. It's a huge challenge of the standardization that I found in the battery as well as motor, which are the main integral part. And the third integral part is the software. I don't think there's any, each company is going to come in with a system like the subsystem that Chandra was talking about. They will bring in system integration, again, their own exclusive one. So I find that today, at least in IC engine, you have standardization at least of raw material. If you buy raw material, let's say steel, there are about 8 or 10 steel that anybody would use. I mean, if for connecting rod, I have 15 different customers across the world, but I use only 3 different type of steel, 3 companies. But is it here I see that this is going to be a huge challenge of standardization not being available. So how does really one cope up to be a supplier of these technologies? I mean, and to be a global player in this. It's something that I find to be very challenging for a company like mine to get into this space and be globally competitive and have the global quality, have all the expertise of different specs, different requirements, and to a large extent, again, whether to what extent it can really be automated is again a question that I'm not very sure, because a lot of electronic components, getting them into system integration, with the volumes that we see in India for a long time, it's going to be a challenge doing automation. So again, manual knowledge, everything that is required is, to me, I see going way forward. Looking at our graph of that, we are one of the lowest, but I would say we have 2 to 3 years time if we don't pick up really fast on creating certain norms for our country which are aligned with the government, I mean with the global. Generally, there's a typical attitude that for India market we can have a particular thing, for another market we can have a different upgrade. And like recently, one of my major customer, who are getting into hybrid, and we were being presented about the vehicle for India and vehicle globally. So vehicle for India is at a lower cost, vehicle globally is at a higher cost. So, we try to, create a product for India, and we are willing to accept a quality or compromise on certain aspects, so keep the cost low. I think that's a big change that I would expect the TV industry should not get into this if we really want to be global players, that we must have global standards right from day one. There is no Indian standard separate. If Indian standard is better than global standard, let the global world change for India standard. But it should not be that we create our standard which is lower than global standard. And that's what I would expect EV industry to really seriously look at. If we want to be, they want to be global players, they want their supplier to supply them parts at optimized cost of global quality, then there should be a lot of standardization that needs to be done.
It's a very, very valid concern. That's why I wanted you to go first, because as you said, you might think that having a substandard or a lower standard will actually help with cost. But as you also talked about, if you have different standards for different customers and different countries, you are not playing with big volumes for each of those products or each of those components, and then that could still have a cost impact, an adverse cost impact. So
cost and quality
I
both.
think, yeah. So
quality comes with
I
the
think
volumes. You are able to bring in better systems.
Right. Yeah. You enable automation. You can justify the cost of automation and so on. So I think over to you, Chandra, for some of these concerns. What are your thoughts on it?
Okay, thank you. I think if I have to, I can clearly understand the pain. Definitely, it is actually the lack of standardization or the need for standardization as early as possible is really quite key. And definitely, as an OEM, we are all feeling the pain as well. Also, the component manufacturers. If I have to just go back and then remember something that happened a long time ago, if you remember, we all had our dialing phone where we actually use our the pre handset thing. So we were there in the industry, and now we are completely transformed into like completely digital, connected, an electrified phone basically. So it's a completely smartphone. So that transition did happen, and if you remember that the amount of different charges that we have got between the phones and the way how the different component manufacturers have to actually go through the pain process and then accommodate themselves. That would be actually as an initial stage of transition. I think we would see that, but that's actually where the automotive manufacturers, the component manufacturers, and the agencies, like the CM and ACMA and the ARI, all the institutions come together and then try to develop a common standard, agree on something, and then help the industry to quickly get a grip on going towards direction. That's actually what I would see as a way forward. Otherwise, the transition is actually will be there in any major trend setting technology development.
So Vikrant, I just want to say that one of the things which global experts are working on is to standardize the charging system. So you have so many charging systems. You have the CCS Combo, Chademo in Japan, GB in China, and the Tesla's unique magic. This is one subject which will hit us. So, like Singhvi was saying, we should zero in on one standard, which is also a global standard. Whatever it could be CCS, but we should standardize on that. A vehicle cannot have adapters for all the world's different charging systems. Second standardization, if it comes in the battery cell level, that would be very beneficial for the country. So I know that Niti Aayog is talking about some Indian, encouraging Indian cell manufacturing. So now today, cell manufacturing is not there in the country. Most of the companies, we are all importing cells, including Ola. If there is an indigenous manufacture of cells, lithium-ion cells, and of a standard size, let's say 21,700, that will really help the industry to adapt the EVs, and more players will be able to aggregate a battery pack using the available Indian cells. This is the core of the technology. Of course, there are many other examples, but that is the core of the EV. So there is a need for standardization for everybody to get together, like Chandra said, ACMA, CIAM, ARA, and work on that.
So I think what I also tried to bring up in the initial part was probably the only apprehension OEMs may carry towards standardization is how do I still have a distinct product from the competition using the same standard parts. So one of the ways which I thought was the tuning of the controller could be still unique. The same subsystem behaves differently when you have tuned it differently in terms of the controller. Any other things that come to your mind which can help embrace standardization at the same time preserve the uniqueness of your product?
Yeah, connectors is one I can think of, definitely. The connectors for the BMS battery, these are all the currently imported parts made by global suppliers, and everybody is using different connectors. Somebody uses 7-pin, 11-pin. So if this is just like we was saying, plug point is nothing but a plug point for the battery plugs. So these connectors are also technology items. They are proprietary items. If we can standardize that, yes, it will help everybody. And it's not a great differentiator that I'm using connector A or connector B. As long as it meets the IP rating, it's good enough.
Vikrant, even today, if you look at IC engine or diesel engine, to a common man like us, what's the differentiator really? Whether the steering wheel or the brake system or the engine performance, mileage, they're more or less the same. Everybody's got distinct, unique engines, unique brake systems, unique all these. But overall experience is more or less the same. In fact, Maruti HR head 7-8 years ago in one of the ACMA conference where I invited him in the HR panel. And he was saying, what's the difference between Maruti car and Honda, any other car? More or less, it's auto, free steering wheel, brake systems, everything is common. Even the luxury inside the car is to a large extent not really, okay, colors, choices of this, so all that we make. Ultimately, it is how companies align to the customer. And that is how so he was talking about how people make a difference in selling Maruti cars. He was giving credit to the human being of Maruti being a market leader for such a long time. So I think going forward, even in EV vehicles, whatever may be the different batteries, chargers, all this, but by way of performance, I don't think there'll be really big difference. Whether you use multiple technologies or all of them use the same technologies. I don't think that would really be a differentiator that a common ordinary user of the vehicle would do. We will probably again look at the gadgets, what are the additional features through the software that is created, the entertainment systems, the luxury in the car, the comforts. I think that's what even today it is happening. So I think it has already gone past that anybody using technology, they can really make a big difference. Very little. Yes, today Mercedes comes out with the latest engine. They have additional features, so they have an edge for next 1 year or 1.5 years. By that time, Audi comes with another engine, so they have an edge. Then BMW comes with a third engine. So it's going on in a cycle that all new features, they get an edge for a short period. But overall, I think the vehicles today, whether it's IC going forward, whatever different unstandardization that you have, but differentiator will be very little. So whether you have totally standardized system or unstandardized system, I don't think you really have a major distinct advantage of being unique to sell your vehicles. Ultimately, it is how you respond through your service or charging or the customer relation that is the biggest differentiator.
So
one key point I would like to add here is that to have the balance between the standardization and the innovation, because that's quite key here. Because having too much of standardization will basically, we need to understand which are the areas that we want to have standardization, all common parts, reduce cost to help us to work along with each other. That's a kind of a focus area. At the same time, going back to your question, Vikrant, that the internal things, the innovation actually stays in the internal design, how we do it internally. That balance should always be there, so that we will still let the innovation happen, same time standardize it for all other benefit reasons.
Yeah, and probably some of the selling points are also shifting towards the ownership experience than just the product itself. So that's also something that we can conclude.
And a first mover advantage which Ather has. That makes a difference, at least.
Yeah, I think we can go to Q&A, but probably just a brief from Arindam on how we are addressing some of these things, like how we focus on, as Mr. Singhvi had said earlier, how to upskill the white collar jobs, how to upskill the engineers and managers to take up the EV tasks that come their way, and that is something that we are trying to focus on. So Arindam, if you can take over, I will just go through the slides. If you can talk them through.
Thanks, Vikrant. So maybe Vikrant, if you can just put on the slide for the program. Thanks. So this is one of the first programs that we are looking at being delivered by the P-Manifold team, who brings in a lot of experience around this space, having been involved with consulting in the space for quite some time now. So the first program that we're looking at is in terms of the electric vehicles. We wanted to get started with a more global view in terms of what are the various subsystems and how do you integrate the subsystem models, having modeled the individual subsystems. In fact, throughout the program, we'll be using open software like Scilab and the regularly used software like Excel, just so that everyone has access to those software and doesn't need any special purchase of a software during the training itself. And one part of the training will obviously look at, one of the most commonly used software being MATLAB. Are there any specific differences when you actually use MATLAB? So that can be done more on a demonstration basis. There will be a focus on simulation and designing and optimizing the specs for the subsystem, and then integrating it into the full EV model. So this is a program I think it will be very useful for a fresh engineering student in the third or the final year, pre-final, as well as people who are in the early part of their career in engineering within the automotive industry. And it's going to be about almost about 34, 35 hours of training, along with practical sessions and assessments that we'll do. And the certificate will be issued by SDC in terms of having a standardized assessment for the whole program. Next, Vikrant. Yeah, so we are looking at building some of the which we are trying to build together, doing a battery modeling and simulation program, which we foresee that we'll be able to deliver from next month with the first batch. We've also, in fact, one of the areas that we got associated first was on the electric bus adoption in the urban mobility space, where the P-Manifold team is already part of the consulting group with the ministry in terms of doing that. So that's another course that we're looking at. This is especially going to be targeted in terms of the state transport undertakings personnel, because that's one area where the training need has been identified, that they need to understand the electric bus system operation in terms of how do you plan it so that you can take the whole ecosystem requirements into consideration in terms of both availability of charge and availability of vehicle throughout the period, because a lot of state transport undertakings are moving into a operation-based model where they engage with the manufacturer, where the delivery is on in terms of the number of hours that the buses actually run on the road, rather than just an upfront capital expense. And then the third upcoming program that we are looking at is in terms of the model-based controls development and calibration of which we expect again. So we're trying to see if we can deliver one program every month to focus on creating a suite of products which once people go through it in those different areas, depending on their interest areas, they should be available for the industry to have specific inputs which they would have gone through in those domains, and be useful for the industry to further give them the exposure while they are within the industry. I think that's the plan as of now. However, we'll keep our eyes and ears open in terms of various inputs and feedback coming in both from the industry side as well as from the academia side, and we'll see if we need to tweak around certain programs, etc. We'll be more than happy to do it as a common partnership that we want to forge ahead in terms of making such programs available to the people who want to skill themselves in these areas. Over to you, Vikrant. Yeah, sir.
Are many of these programs aligned with any OEMs or in tie-up? Like, for example, bus, is it with any company or just on your own?
So this is largely being driven through.
Sorry, we can't hear you.
Can you hear me, sir?
Yeah, now we can.
Okay, so I think the plan is to offer it to the state transport undertaking employees in partnership with the state transport undertakings, and we've been in this across various states where they have already added electric buses, but probably are currently struggling to run them in an optimized model as to how do they plan the operations for running these buses, maintaining them, charging them, etc.
Yes. No, one of the ACMA members, Nishant Arya, was very keen in working on this.
I will have to speak to Mr. Arya and then also look at, because they are already partnering with various state undertakings, in fact, on the electric buses. Yeah. Over to you, Vikrant.
Thank you, Arindam. Yeah. We have few questions from the audience. We are running a little late, but I hope from the panelists, if we have some more time to answer these questions. One of the questions is, in your estimate, in how many years the EV cost will be comparable to IC engine costs? Now, this I think refers to the initial cost, and typically batteries being very heavy portion of the cost of the EV. So maybe Chandra and Mr. Kaustavan, if you can try answering these in turn.
So the analysis from the car point of view, I'm only speaking from a car point of view, is that when the battery cost globally becomes somewhere around $75 per kilowatt hour, that is supposed to be the tipping point when the battery cost will become the EV will be same as the cost of the IC engine vehicle. And there is a Pareto chart for that, which shows that the remaining commodities in the vehicle, like BIW, suspension, brakes, these are all commodities that are going to be more or less carried over from the ICE. So the remaining cost of the battery and motor controller, as juxtaposed against the ICE, this is the break-even cost, $75 per kilowatt hour, and that is expected to happen in the next 5 years, as per some estimates. However, having said that, Maruti has come out with also a statement, right, that it is not possible to make a low-cost electric vehicle. If you look at all those statements, part of the challenge in passenger car industry is meeting the crash performance. So frontal crash and side crash for an electric vehicle is much more challenging than for an IC engine vehicle. So to that extent, the cost of the body structure does go up a little bit. So several compensations have to be done in order to bring the initial price of a passenger car EV to the price of a IC engine vehicle.
Okay, I think pretty much actually Kaustavan actually covered the crux of the idea here, because the battery cost is actually one of the key parameter which actually determines the when we will actually become at par with the ICE vehicle cost. So again, there are a lot of estimates, there are a lot of studies going around, and one of the studies says that around 2023 we will be actually seeing at par vehicle price for 2 and 3 wheelers. 25 will be actually for 4 wheelers, like 5 years from what Kaustavan said. So there are a lot of estimates going on, but they're all actually linked to the battery kilowatt hour price, basically.
Thank you. Also, there could be some different ownership models where I think Mahindra Electric is already trying a battery lease model instead of you buying the battery along with the electric vehicle. So there could be some solutions, non-technical solutions to this as well.
Yeah. So the question was earlier about the price will become actually at par. That's the answer. But when you talk about actually, can we afford it? Answer is basically yes, we can afford it, because one is actually the subscription model, even as well the recent 450X that what we have launched. So there are a lot of subscription options that they are giving. So in terms of you don't actually own the whole vehicle, you pay for the usage of the vehicle, and in terms of multiple benefits what you get, etc. So the affordability of owning electric vehicle is actually, and also the in terms of the total cost of ownership is also, if you look at the over a period of time, that actually again a different mathematics goes into the picture. And if you compare versus ICE versus electric vehicle, then it will be a different question altogether.
And similarly, for Ola Electric believes in the swappable battery technology. So the battery is distinct from the vehicle, and the customer need not buy the vehicle with a battery, and he can just take it out and exchange it for a fully charged battery and keep running the vehicle. That's our model.
One question of mine, Mr. Stevens, one question of mine. When you say $75 is the equivalent cost to IC engine ownership, are you factoring in the cost of just the vehicle and not the running operating cost? When it comes to operating cost today, when we talk about, government takes about 80% on the diesel and petrol as a tax. Now, so are we factoring running cost, keeping the taxes in mind? Because how would government generate the revenue if oil and diesel prices go away? All the state governments will become bankrupt. So they'll have to bring in some tax on electric energy or surcharge. What is it that would happen to the government? So And secondly, I think the cost also depends on the volume, how fast we reach the volume. So that also is a big factor.
So this is slightly out of the technical discussion, but a very good question which you asked. In the case of fuel, fossil fuel, government is importing and refining it. So petrol, gasoline is a refined from crude. So government is adding value. So they are taking a lot of taxes out of that. So if, on the other hand, if myself and Chandra were to import certain cells from Korea, there's no value addition from the government, zero. So why should they put tax on?
No. Tax is nothing to do with that. Is charged by the oil refineries. The value add that is charged separately. State taxes is 70%. That is nothing to do with value add. It is just the revenue or not, like tobacco is cost charge. This is a challenge that you have to look at.
And more from distribution cost or whatever. I don't know. So I think there's another question on the having programs like this and having application like this. Do you think these kind of people will be useful for the industry? Will they be accepted? Or let me put a straight question: would you want some of your young engineers to go through a program like this, for instance?
Yes, my side,
Chandra,
looks good, Arindam. It looks good. I will take it back to my management and ask them if they are interested.
Sure.
How long is the duration? That's what I want to, when you said starting mid-September or November, how long is this program?
These are being done virtually. 3 days in a week. They have some classes online, and there is some weekend additional practice sessions for practicals. And the whole thing will be done through in 5 to 6 weeks.
Okay, that's good.
Yeah.
Thanks for presenting.
Dr. Chandra, any views on the value of programs like this?
Okay, I think looking at the content, Arindam, so I can actually see that it's pretty much actually going towards the left side of the system, V mainly, which is the initial phase. So I think it's a good start, I would say, in teaching people to understand about AV different systems, and then how do they use actually mathematical modeling to develop systems? How can it's actually a good flow process. It's a good start, I would say. But when actually will this be actually useful to industry? Answer is yes, but to be a very particular focused group of people that we will use it within the industry. I think probably we need to go more and more towards how do we actually give the practical experience of all these modeling and simulation. They need to actually ask the question, the why question. Why am I doing it? What is the reason? If I get this value, what does it mean? So rather than being too academic, they have to be more pragmatic as well. I think as long as that message is actually there, it is actually a very good course for the purpose what you have just given you.
One more global EV export trainers, is it possible to have a view of to deploy on this training program?
Sorry, I think you have to talk again, Srivats.
Yeah, the voice was breaking up.
You have mentioned global EV expert trainers, right, on the right hand side. Is it possible to know who are those trainers, the expert trainers, the names and their biodata, so it will help us to kind of justify these programs within the company? We can't hear you.
Yeah. So, it will be part of the brochure. I am one of the trainers myself, and then we have Rahul is there, and then we have also on certain specific modules we are getting guest lecturers from the industry. So we will supply you with that information.
Sorry, Vikrant, I think we are at about 4:45 now.
I think we have,
so maybe we should wrap it. We can reach out to those individuals directly and also to our experts to seek their views on some of these questions later. I think from my end, a big thank you to who've participated today in the panel, and also the audience who've made this possible. And I think this is just a beginning that we've made more on the electric vehicle adoption and the skilling efforts. We have a long way to go, but you always have to make a beginning. And thank you for being there with us to support us on this journey. Vikrant, anything you want to add?
Yeah. As Arindam said, thanks a lot for your time. All these views are extremely important. I mean, for us as well, to incorporate into whatever we do. It gives us focus. It gives us thoughts to set priorities. So thanks a lot for all your time, as well as for sharing your views, your expert opinion. So yeah, thank you. We can wrap up now, and yeah, have a good evening ahead.
Thank you.
Okay, thank you very much.
Thank you.